Okay guys, so in this video we have added support to search for emails. So let's have a look at that. So now I can go up here and I can do a search for say ASD, and we can see that now we've actually been shown a result list of the different hits here, and I can tab between these and I can search for foo and I can find results on that, or foo town like that, or maybe I just want to search for a date like that, and then it starts matching against the dates and so forth. Now we could probably enhance this even further, but for this application I think this is good enough because there are more advanced features where we could possibly highlight the matches that we made and so forth, but that's actually fairly complicated and a little bit out of scope for this, I would say. But let's have a look at how to support non-trivial searching. So the way that or rather the way that I approach this is to use Elasticsearch. So I've added a search service to my Docker Compose file, which is going to be in the Elasticsearch image, the official one, and that's about it. The reason why I want to go this route is because searching is one of the hardest things that you can possibly do in an application, hands down. It is very, very hard to implement good searching by yourself, and Elasticsearch is probably the de facto standard for searching large documents. And since we want to be able to do full text searching in our emails, even if, let's say, for like right now I have a very simple implementation, but we might actually have future stories that where we want to enhance that and make it even more robust and even better and create even greater relevance. And creating that from scratch is just not practical. So when there's an off-the-shelf solution like Elasticsearch, it's actually a really good idea to use it. I use it like professionally. This is the way that I would go. So let's just have a look here. So all I've really done here is that I've added support for, or rather added the Elasticsearch package, the client library, to our dependencies. And if we now have a look at this endpoint here that we've added, we can see here that, all right, so we have this search endpoint and we grab the queue or query parameter and the offset and the limit, and we do the same sort of parsing we've seen before. And now we simply have a search method on the email service. And apart from that, we've added a query to count emails. I'll touch on that in just a moment, why we actually now have to pass a query to counting emails. And then I also added just a little bit of a log, an error log here so that, when there's an issue with something, we actually see a log in the output of the container that we are running. And now we can see that we've made a few updates to the services, or the index.js for the services. And basically what's happened here is that I'm instantiating the client for Elasticsearch. And then I have this search service, which I instantiate with my client, and then I pass the search service into the email service. But I also export both the email service and the search service for convenience purposes. But yeah, that's virtually it, really. And we'll look at that in just a moment. This is a little bit of a philosophical thing. If you should have services who depend on other services, and I'm in favor of that because I want my email service to have an easy time handling searches. And there is now a correlation because we have two different databases where we want to be able to make separate storage solutions, have separate storage solutions for each of them. And we'll look at that in just in a moment here to kind of illustrate how this is going to work. So we can see here that search and count emails are the ones that have gone through the biggest change, but we also have quite a few changes down here in create email and so forth. So what we're going to do is we're going to have a little bit of a dive into our email service now, because it's code-wise it's a small change, but it's a very dramatic change in the way we have to think about our application. So we have a search service that is now a dependency for our email service, and the search function here as we saw earlier, it takes a query, an offset, and a limit. And what it will do is that it will talk to the search service and call find email. And basically, all it's going to do is that it's going to go to Elasticsearch and it's going to, well, basically make a search for the possible, and get the results. And then we will get a result set that is specific to Elasticsearch, and basically we just do a little bit of data formatting here where we just extract the ID of the resulting documents that we get back from Elasticsearch, and then we query MongoDB with that array and just grab all of that. And the reason why we do it this way is because we don't want to, like, the things that are searchable for a user is ideally, or rather in this very simple scenario, we'll look at it in just a moment, it's just a part of all the things that are on our base model. In other words, we don't want to just cram everything that is on the email model in MongoDB into Elasticsearch, because that's just not practical, because a user will not want to search for the viewed at timestamp, for example. There's no point in having that in there, so you have a partial set of data there. And that creates a little bit of a coupling between these two and a synchronization situation, which means that we need now to make sure that there is a corresponding document in Elasticsearch that maps to an email model in MongoDB. And that adds a bit of complexity, but all things considered, I think that's a fairly good trade, because to put it simply, as I said earlier, it's too complicated for us to make non-trivial search algorithms work in MongoDB. So we need to remember that there's a synchronization now. So there has to be a corresponding email document in Elasticsearch that maps perfectly over to a corresponding document in MongoDB. So we have to keep that synchronized. Anywho, so count emails now takes a query, and the reason why we want to make this query is because we can no longer just go to MongoDB and count the type of search, because we don't have a email type that maps to, there's no type search, or there's not, if we want to be able to count the amount of emails to show, or remember, in order to show this number, the total amount of emails we have for a search, we need to somehow figure out, okay, so how many how many of the total are we going to, how many emails are there? And in order for us to do that, we need to do that in Elasticsearch. I hope that makes sense to you. So we can't go to MongoDB and ask that question, because that MongoDB doesn't know how many documents will be returned from making a query. So we actually have to go to Elasticsearch and make the query and return the result sets of how many documents would we get back from that query. So apart from that, well, let's have a look at actually creating an email. So that is actually now a two-part thing we do. So first we have to create the email in the MongoDB, basically, and then we have to save that email, or rather extract that information and save a separate document in Elasticsearch, so that the user can search, because as I said earlier, that we're actually going to Elasticsearch when we're searching. We're not going to MongoDB. We're going first to Elasticsearch, finding things that the query is going to match, grabbing the IDs from that, and then going to MongoDB. And the same thing goes for any write operation. So as soon as we want to write to our database, we need to make sure that we are actually also writing to Elasticsearch. So hopefully that is and the same thing goes for remove here. So we have to remember that, okay, so first we go and grab the email we want to remove from MongoDB, and we also we call the delete email method on the search service with that, so that we make sure that it's consistent. So we remove the email in both of these databases. And what else is there? Well, we've added a few simple tests, so we don't have to get all too fancy with this. We can probably expand this a little bit here. So most of this is just now, because we have this mock email service, we can actually go to this and just look at it a little bit closer. So you can see here, most of this is just updating the expectations. So as we saw earlier, when I create a draft email, I now expect there to be a call to save email on the mock search service. And this is once again where I think that this idea of injecting your dependencies instead of having them required inside of the module is the way to go, because now it was very easy for me to just, all right, I now know that when I call, like when I call create draft email, I expect there to be like I want the model to be called with these parameters, and I want my mock save function to be called, but I also want the save email method on the mock service to be called. It's very easy to just add onto your tests. We'll not go through all of this, but I can just scroll through a little bit here. There's quite a few updates, and it's not all that different from what we saw earlier. It's just changed expectations basically on what we are going to, in the assert for the test. Anywho, search service. This one is a little bit interesting because it's completely new. So basically, the search service takes in the client, which is our reference to Elasticsearch, and then we have a save email, delete email, find email, and count found emails. So count found emails. Now this one is important because, as I said earlier, in order for us to know how many, what this upper bound, the total of the search hits is going to be, we need to actually run the query. So we do it twice basically. We run one query to grab the emails themselves, and we will run one query to count how many we are going to, how many there's going to be, in order for us to support pagination in searching as well. Because imagine this, like if I give this a star like that, well then I'm at, you know, quite a few more of these hits, and I still want to be able to page through all of my search results. So basically what's happening here is that we are calling the count function, or the count method, on our connection to Elasticsearch, and then we have just specified a query body, and in this case we're going to use simple query string, which is the one that is probably the most suited for user-facing searching. And I mean, you can make a lot more complicated queries with Elasticsearch than this. This is just me kind of keeping it simple, because going really deep into this is a little bit out of scope for this tutorial of mine. It's a completely, like, there's so much more you can do with Elasticsearch. It's really powerful. But anywho, find email, as we expect here, we have our query body, and then we have a sorting order, because I actually fixed that. I actually noticed a small bug that I had where I didn't sort my database results, so I've fixed that as well in this video, so that we actually get, you know, when we're using pagination, we want to make sure that we are not just sorting based on the timestamp on the client, as we've seen before, where we do that sorting in the browser, but we also need to make that sorting on the server now that we're using pagination, because now we're not just grabbing everything, we're just grabbing segments, and those segments needs to be in the correct order. And then we have a support for offset and limit here as well, so we can actually support pagination in our search queries as well. And then basically we get the response, and there's a hits object and a hits array where all of our results from Elasticsearch live. And then we have delete email, where basically we just support deleting a specific document in Elasticsearch, and if we don't find it, we simply ignore that we don't find it, because otherwise Elasticsearch will throw an error. And yeah, basically, and then we have save emails, which is probably the more interesting thing here. So we grab the email that has been created in MongoDB, and then we call create, and then we specify an index, because, you know, we need an index space. And then we have our ID, which is going to be the email ID, and then a type of the document, which is just going to be email. You can make this more specific if you wanted to be more fine-grained, but we don't really need that. And then in our body, we simply grab the fields that are important to the user for search purposes. So this is not just me grabbing the whole email. That doesn't make any sense. I just want to grab the recipient, the subject, the message, and from, and then I need the timestamp in order to do sorting, basically. So yeah, that's about it really. And then in our application here, there's quite a few things that have changed as well, because I noticed something that I had missed in a previous video, which is that, hey, I'm not actually using the path anymore, so we don't actually need to specify a path in our routes. So I simply changed back to, instead of using render, we are using component and just passing that in like this. And then I've also added a route for searching, which is the route that you saw that, that's what we hit when we actually perform the search. And apart from that, we've added a bit of as we can see here, there's a there's a container now for our header, and we'll look at that in just a moment. And yeah, that's about it for the app.jsx. And there's some interesting stuff. So let's actually go into this and have a look. So in order for us to be able to express different queries, as you may have noticed when I search here, we see that there's actually an added query parameter here. And the reason why we want this is because we want React Router to pick up on the fact that we are actually changing routes. So if I'm on the inbox like this and then I make a search, you see that now we're redirected to search because we are reusing the inbox component, but we also want to grab the query parameter here, and that's not something that's going to happen without a little bit of trickery, and that's what we're doing here. So the header, in order for us to be able to support actually grabbing the to actually be able to grab the actually maybe this is easier to actually understand here. So what we want to do here is to simply wrap our header component in with router. And the reason why we want to do that, if we go from that perspective, is that with a router will allow us in a programmatical fashion to get access to different libraries that we are provided by React Router, or rather which React Router, or in this case React Router DOM, provides us with. And one of those, it's not the only one, but the one that we're interested in is the history API. And the history API is just basically like a reference for us to the browser's history, so that we can actually change the history tabs, or like the history that we create for when the user is making different queries. So when a user actually submits the form, what we want to do here is to, if we look at this piece here, we want to look if the path name is equal to the search template. In other words, are you on the search? Because if you are on the search, I want to replace the current browser history with an updated version of the search URL, instead of just pushing things onto the history. Because you may have noticed when you use a browser, if you just keep on clicking links and you go backwards, you have to go back through all of the different routes that you have gone to. But I don't want that behavior for a search, because if I'm sitting here and I'm like doing foo like that, and then I just keep on clicking over and over and over and over, I don't want to have to click through all of those queries. I just want to be able to click right back, because I was on the inbox and now I'm on, and now I have the query, right? I don't, as I said, I don't want to force the user to click through like 100 pages of searches, because it's just not a good user experience in my opinion. So that's basically why we have this with router, so we can have access to the history API. And yeah, let's see if there was anything else in the diff. So yeah, I fixed the missing props passing to our super function or so forth. And we've also added a name to the input now, because we actually need to extract, we actually grab the value from search, from that field. And this is just making sure that, hey, if there is no value, if it's empty and the user tries to submit the form, we simply just ignore it. And then the container has an onSubmit function, or rather there's a little bit of things going on here. So let's see here, header container. Yeah, basically, is this really, yeah, it might be. Okay, I see that I've missed to remove a few things here. These things are pretty much like this was a copy paste, so let's actually remove that. There's no point in having these there. So basically all onSubmit does is that it's going to go to the inbox actions and create send a dispatch of query was made, and we'll look at why that is in just a moment. So in the inbox, the main thing that's changed here is basically that we have a component will receive props method that we've added, and let's just look a little bit closer at that. So the thing here is that when we receive the next set of properties, we want to check if the query was made, or rather if there was no new query. And the reason we want to check for this is because this is the way that we know that the user has actually changed something. Because remember, React Router will only reinitialize or remount a component if the route changes. But when I click foo like this thing will actually not re-render. Like if I just keep on clicking this button, nothing will change. Like the DOM tree won't update. So in order for us to actually express to our inbox component when it should refetch the emails, we have to actually explicitly say that, hey, a query was made. And that's what we're doing here. We're basically just checking if this Boolean value is there, and if it is, we simply return. And then we have an onSearch, which is, we can just really quickly dive into the onSearch here, I think. And onSearch, as you may expect, is just going to reset that value to false, because we just want to do it once, and then we want to go back to just not having that at all. And then apart from that, we simply, we have this fetch email method that we know since before, and we're simply going to, we've added a query parameter to this input, and all we're going to do is basically the same thing we've done before, but with the added complexity, if you will, with a query. So if we look at the properties we're passing in now, so in order to get the query parameter, we simply go and look at the location. This is the way that React Router will actually pass in these APIs I was talking about earlier. You remember I was using with the router in order to explicitly say that, hey, I want the location object. This is the same thing. It's just implicitly done through each of the routes. So you can actually access these different APIs. I could actually do this as well. I could do this and grab the history API as well, but I don't need it. I just need location, because I want to grab the search property on our location for the browser, and then I wrap this in a URL search parameters, which allows me to get the query from the URL, and that's what I want. And here we see that query was made is also being passed in. So fetch email is now even a little bit more complicated. We might want to, I still don't think we should refactor this, because a lot of this is just extracting values, but we're getting to a pain point or a pain threshold for this. And basically fetch email now also takes in a query. And the reason we want to do that is, as I've mentioned before, in order for us to be able to count how many emails is in the total data set, we need to actually pass in the count, the query parameter to our search, or to the request for the count of the total emails. So if we look at paths here, we'll see that email count in this case has been updated. So in order for us to be able to support this type of functionality, we've added a query parameter to that URL. Earlier, as you see, we didn't have that. We just had the email type, but now we also have a query. And as I said, it's because in order for us to be able to know what the total is for searched emails, we need to have that. And then we see that we've added a search path as well, which is, yeah, it's basically just, the same thing with an added query parameter. And yeah, that's about it, really. I don't think we have to dive too deeply into that. Let's go back to actually looking at this thing here. So that's about it. That it's not that much of a code change in the inbox. And then we of course have a few changed boilerplate things like query was made, that action is added, and then we have the event label, which is just query was made. Nothing so especially exciting there. And here we can also see that there is a new property on the initial state, and query was made has been added as one of the cases in our inbox reducer, and all it's going to do is that it's going to set that property to whatever value we pass in. Fetch email has, I've fixed a small bug as well that I found, which was that I had forgotten that when we go to root and to inbox, we want the same behavior. So there was actually, it actually broke. So I added a case for root as well. And it's just basically the exact same thing as inbox. Now that I'm actually looking at this, we could probably just do this instead. Can do this to be a little bit more consistent with things. There we are, and then we have a case for search template. Let's go in and look at that more in detail. So we do a very similar thing as you saw earlier. We basically go to the search property on the location object in the browser, and we get the query, and then we simply pass that in instead of like adding another input parameter. We might change this in the future. This has made this fetch email method a little bit less testable. But I think all things considered, yeah, for now it's okay. We might change it. We might change it. I'm not sure. Anywho, then we have this other thing where we just map the email type, and as you can see here, I fixed this issue here as well, because hey, root and inbox should return the same value for mapping the path name to an email type. And then we've added a case for search template, which is going to return search. And I also realized that I made a mental mistake. I've hard-coded these string values here instead of just referencing the paths templates that we have, or the paths that I have declared in my paths file. So I went over and started using that instead. So continuous refactoring, the Boy Scout rule. You find these small little issues as you work and you improve them. Right, that's about it. I know that this was a lot of content, but now, well, pretty much we have, yeah, thanks to Elasticsearch, we have support for searching, and we can also expand on it if we want to improve our search functionality. So I'm going to call this ready for testing, and then we will see here, okay, the next thing is to add register, or being able to register a user account and actually create your own account. So let's have a look at that.